Today we're talking graphing quadratics in Vertex form. Hey guys, Jesse from Capstone Academics here. Today we're talking about graphing quadratics in Vertex form. I'm going to be taking you guys through a rapid-fire series of graphs that will help you learn how to graph in Vertex form. And at the end, I'm going to have a two-problem test, which, if you can pass it, means you're ready for your quiz, your test, your midterm, or your final. You'll be graphing in Vertex form when the equation has the form y equals a parentheses x minus h squared plus k. So first things first, I'm going to go ahead and put a formula sheet on screen for you guys. It'll be available in the link in the description below as well. But go ahead and pause the video and either take some notes if you feel like that'll be most helpful, or just take a screenshot and save it for later. But in any case, you want to give this a brief look over just because it'll be easier to understand the problems we're about to do if you've given this a look beforehand. So now that you guys have a basic understanding of what everything in the formula actually means, I'm going to go ahead and give you a rapid-fire series of graphs where I illustrate each independent transformation in every next graph, and then I'll sort of bring it all back together so you guys can learn this as efficiently as possible. Alright, so first one, guys, just the really basic y equals x squared equation. If you want a little table of values to help you understand exactly why this looks the way it does, I'm going to sneak it in right here. So I'm not going to do this for all of the equations that I'm giving you here, but it helps to know just why this parabola has the shape that it does. So if you plug in x's from -2 to 2, that's enough to sort of give you an idea of why this thing takes the shape that it does. So if you're just plugging in 0 here for x, y equals 0 squared, that would give you 0 for y, and then 1 squared is 1, and then 2 squared is 4. And then if you do -1 squared, that's 1, and then -2 squared is 4. So if I plot those, 0, 0, and then 1, 1, and then 2, 4 would be right there, and then -1, 1, -2, 4 right there, and then if you draw a nice curve through the points here, you can see it taking that parabola shape that you guys are so used to. So this is what the basic parabola looks like. Now we're going to get into basic horizontal and vertical shifts. Now, if you look at the formula that I have for you up on screen there, you're going to see that the number at the end, the k, represents a vertical shift. So this is going to be the same exact graph, but just bumped up 2. So if you just go up 2 here we are at 2, go ahead and draw your points in. I'm just going to do 3 for these rapid fire sketches so you can get an idea of what numbers where do what, right? So numbers at the end after the x squared mean a vertical shift, so it just goes up 2, normal looking parabola. And then over here, when we have x minus 3 squared, if it's in the parentheses like that, then it's automatically a horizontal shift. And the thing you have to be careful of here is that the sign in here is always going to be the opposite of the way it shifts horizontally. So when it says -3, you might think it goes to the left 3, but horizontal shifts are opposite because they have a negative built into the formula, as you can see up there. Okay, so this actually means you went to the right 3. So 1, 2, 3 to the right, and just make a couple points there. And then nice smooth graph. And yeah, so we've got original vertical shift with the number at the end, and then horizontal shift with the number in the parentheses. Just remember, that's going to be opposite. Okay, so as you can see here, I've got a combination of the horizontal and the vertical shift that I put for our first view here. So it just goes to the right 3 because that minus is opposite, right? So to the right 3, 1, 2, 3, and then up 2. So there's our vertex, and then you just go up 1 over 1 for our first couple of points. I'll talk about that here briefly, but that's using the A trick that I mentioned in my other video. So now we're talking about modifying the A value in the next couple of problems here. That A value is what controls whether it goes up or down, like right side up or upside down, and also whether it ends up skinnier or wider than the average parabola where the A value is 1, like we're seeing here. This is what you'd call a normal width parabola, right? Because the A value isn't modified. So if you look at this one, the way you want to think about this is that this graph is growing 4 times as fast. So basically it starts at 0, 0 because there's no horizontal shift and there's no vertical shift, right? Like we had back there. But it is growing 4 times as fast. So you can use this A value, the 4, to go up 1, 2, 3, 4, and over to the right one and to the left one to get your first set of points. It's a really nice trick. Works for all forms actually of quadratics, but yeah. So what you want to remember is that if the absolute value of A is greater than 1, then that means it gets narrower or skinnier than usual because that growth is getting multiplied by a number. So it ends up growing really fast in the positive or negative direction. This time it's positive because it is positive 4. So yeah, looks narrower. Now down here, if you look at y equals 1/4 x squared, again, you have to, I mentioned this in my other video, but you have to be really careful when you're using this A trick, because if you're thinking about it the way you would slope-intercept form, you might think you could go up 1 and over 4, but it doesn't work like that. So with quadratics, you can only go up literally 1/4, so like 0.25, and then over to the right one. And this is how you get your first couple of points like that. So if you look, we're getting a much wider parabola, because this time it's growing 1/4 as fast as the normal parabola. So it gives it that really wide look. And it's right side up because it is positive. We'll address the upside down parabolas shortly. Okay guys, so last quick sketch to go over is if the A value is negative. All that's going to do is flip it upside down. There's no horizontal or vertical shift here, so it's just going to start at 0, 0, and then go down 1 over 1, if we use that A trick there. And just normal parabola, but upside down. So that's what a negative A value does. Now, moving over to here, I'm going to go ahead and put the exact steps for graphing these on screen. If your teacher requires 3 points or 5 points, you're going to need to create a table of values to actually show your work, like here's how I centered my table of values at the vertex, and then got other points around the vertex to complete my look of the graph, right? If it's upside down, as we're going to see here. So first thing you're going to want to do is find the vertex. So for this one, remember that horizontal shift is opposite. So when it says +4, it really moves to the left 4. So -1, -2, -3, -4, and then up 2. So 1, 2. So that's the vertex. Now, second step is to just ask yourself, is it right side up or is it upside down? So because of this negative A value, it is going to be upside down. And then is it skinnier or wider than usual, or is it of normal width? And you just have to look at the A value for that. It is a fraction, it's 1/3. And remember, if basically the fraction is in between 0 and 1, the absolute value of it, meaning like ignore the sign on it, basically if it's a fraction, a proper fraction, it is going to be wider than usual because it's growing at a fraction of its usual rate, giving it a nice wide look, and it is upside down, so we can expect it to basically look like this, a little wider than usual and upside down, right? Now, if all we have to do is sketch it, which is actually kind of uncommon, you could just use that A trick of, remember, you can't go down 1 over 3 the way you would with a line. You have to go down 1/3, so like down 0.3 and over 1. So these would be our quick points, and then you could sort of connect it and sketch the parabola that way. But most of the time, at this stage, you're going to have to create a table of values. So I'm going to create a quick table of values here off to the left. Make sure to center it around the vertex. That's super important. So that's -4, +2. So -4, +2. And you want to go down a couple x values and up a couple x values to find surrounding points. Now, I'm going to do something kind of special, a nice trick here to avoid decimals. Because my A value is a fraction, I'm actually going to go over to the left and to the right on intervals of this denominator. So this will ensure that when I actually do this part out, the result is divisible by that denominator. So you'll see what I mean here in a second. But basically, instead of going like down 1 and up 1 from the x here, I'm going to go down 3 and up 3. And then I'm going to go down another 3 and up another 3. So remember how we can use that axis of symmetry, this guy, to mirror the points across. So we really only need to plug in 2 x values. You'll want to plug in the ones that are closer to 0 because they're going to result in lower numbers to work with overall. So just making your life easy, right? Just a couple pro tips. So plugging the -1 in, I'll show my work here. It looks like this. And then if you look at what we get from the -1 + 4 squared, that's going to be -1/3 times, this is 3 squared, and then -1/3 times 9 + 2 gives you -1/3 times 9 gives you -3 + 2. So y is -1. So -1, and then I can mirror it across my axis of symmetry, and I'll know that -7 would also produce -1 for a y value. So quickly, I'm just going to do my 2, and we'll see what we get for our 5th point here, our 4th and 5th points. So plugging 2 in, y equals -1/3, 2 + 4 squared + 2, and then -1/3, this is 6 squared + 2, negative 1/3 times 36 plus 2. This is going to be, if you're multiplying by a third, by the way, that's the same thing as dividing by 3 in case you didn't catch that last time. A third of 36 is 12, but it's negative 1/3, so negative 12 plus 2, y is negative 10. So I can mirror that across over here as well. Now I'm just going to sort of plot these. Negative 1 is right there. Negative 7, negative 1, so that's negative 5, 6, 7. And then we've got 2, negative 10, which is there. And then negative 10, which is here. So connect that all, the nice parabola there. Whatever you do, don't make these a V. I've seen teachers take off for those all the time. So, yep, nice wide upside down parabola as we expected. Okay, so those are pretty much the most challenging ones that you're going to see. I have another quick one here for practice. Again, step 1, go ahead and find that vertex. It says -4, but horizontal's opposite, so we go to the right 4. 1, 2, 3, 4, and then down 3 because vertical behaves normally. Negative 1, negative 2, negative 3. Is it right side up or is it upside down? Well, that's positive 2, so it's right side up. And then if we use our A trick for a quick sketch, because you guys know how to do table of values here, like a worst case scenario like that, so I'm going to skip that. But you go up 2 over 1 here, up 2 over 1, draw that nice skinny parabola we would anticipate because the absolute value of A is bigger than 1, which means it grows faster than usual, so it's going to have that skinny look to it. If you guys are finding this helpful, please do go ahead and hit the like button. Thank you so much. Okay guys, so real quick, we just have to talk about when h equals 0 or k equals 0 or both, because they can look a little bit weird, but these will go really quickly. So for these, we're just going to do some sketches just as little reminders, because you guys actually saw some of this in the initial quick graph. So if we look at this, there's no vertical shift because there's nothing after the squared, but there is a horizontal shift to the left 2. So we're just going to go to the left 2, and then right side up or upside down. It's upside down because of that negative, and then skinny or wide. It's skinny because the A value, or the absolute value of the A, is bigger than 1. So it's going to grow steeper than usual. So down 3 over 1 if we want to use the A trick. And there we go, there's our basic sketch, right? Now, if we look at the second one, there's no horizontal shift, so h equals 0. But there is a vertical shift, it went down 4. So down 1, 2, 3, 4. And then if we go up a half and over 1 in either direction, that'll give us a basic idea. It is right side up because it is positive, and then because it's a fraction, it's wider than usual. So we've got something that looks basically like that. Now, over in the third example, we don't have an h or a k value present, which means it's centered at the origin. So it didn't shift left or right or up or down, so just right at 0, 0. And then upside down because of that negative, and also wider than usual because of the fraction. So down a fifth, so very wide. And then over to the left and right 1. So something like this is basically what it looks like. There you go. Okay guys, time for the 2-problem test. If you guys are good with these two, then you're probably good to go. So for our first one, we just need to move to the left 3 to get our vertex here. So 1, 2, 3, and then down 1. There's our vertex, right side up or upside down. It's upside down because of that negative. And then 2 will make it skinnier than usual. You can go down 2 over 1 to get your other 2 points if you're just sketching it, or just use a table of values and get your other points, but it basically looks like that. No problem, right? So over to the next one here, there is no horizontal shift, which makes it look a little weird, but that's okay. It just means we're not going left or right at all. We are going up 1 though because of the vertical shift. So our vertex is here at 0, 1, and then it is right side up because A is positive, but it's wider because of that fraction. So up a third and over 1 on either side if you're sketching, or just use table of values, but it will end up looking super wide, just like that. And that's all for graphing quadratics in vertex form. If you guys found this helpful, please do go ahead and drop a like. Thank you very much. I really appreciate it. And lastly, you guys are probably going to be graphing quadratics in standard form if you haven't already. Usually that's what teachers start with, so you probably saw that right before this. But in any case, I did make a video about that. I'll leave a link to it at the end of the video here, along with a link to my video about graphing quadratics in intercept form, which some teachers skip, but it's super useful to know for the SAT and the ACT, so I would check both of those out. Thanks so much for watching, guys. See you next time.